What's up guys, welcome back to the channel. In today's video, we are going to be going for Kubernetes for modern data engineering. We are going to start this video by going through the details of Kubernetes and how you can get it set up on your local machine. We are going to, after getting it set up, we are going to go over and set up our Kubernetes dashboard where you can visualize everything that is working on your Kubernetes cluster on your local machine. Once we are done with that, we are going to go over to Apache Airflow and get Apache Airflow installed on your machine, on your Kubernetes cluster. Your Kubernetes cluster will be set up to run Apache Airflow without so much of a stress. If you are new here and you have not subscribed to the channel, don't forget to subscribe, like, comment, and share this video with your friends and colleagues. If you're a subscriber and you have not joined our membership club, I will recommend you join our membership club where you have special access to behind the scene content, you have early access to videos and a lot of perks depending on your membership level. So enough of that, let's get into the video and let's get you started with Kubernetes for modern data engineering. Let's get started by installing Docker on our machine. This is very important because the infrastructure we are going to be writing on is going to be leveraged heavily with Docker. So let's get started with that. The first thing you need to do is go into docs.docker.com/get Docker. I'm going to leave the link in the description in case you need it. All right, so I'm using a Mac, so I'm going to be going for Docker Desktop for Mac. But if you're using Windows or Linux, you have to just select the kind of operation you're working with or operating system you're working with, and then you can install it. All right, so I'll be selecting Docker Desktop for Mac. And you have two options for Mac. You can use the Apple Silicon or the Intel chip. So I'll be selecting the Apple Silicon, which is the one that I'm using. All right. And once that is done, I just download that. Wait a few seconds for the download to be completed. And then we continue. Now, while this is going on, if you have some system requirements information that you want to do, you can do all these informations, all these operations, so you can get them installed on your machine correctly. But right now, I don't need to do that. I just need to come in here and download it. All right. I just clicked on that and then I can get it installed. Well, I have Docker installed on my system, so I'm just going to simulate that. You don't have to do this step if you have Docker installed already. So I'll just drag and drop this, and it's going to ask me if I'm going to be replacing that. Yeah, it says it's because it's still in use, so it's okay. Well, if you don't have it on your machine, that step is going to just easily install Docker on your machine. Now, once that is done, the next thing you want to do is go into your Docker desktop. All right. On your Docker desktop, you are going to see the containers that are running on your machines as well as the images of those containers. So right now, I don't have any container and I don't have any of these machines that are currently running. I actually shut them down. All right. So now, easily, if you want to configure Kubernetes, if you want to get Kubernetes enabled on your machine, the first thing you want to do is come into this section, and in the resources tab, you have to enable allocate more resources so that Kubernetes can be configured properly on your machine. Otherwise, if you have a low system or low memory machine, you may not be able to use Kubernetes on your Docker desktop. But in this video, we're going to be using the Docker desktop, like I said. And these are the configurations that I'm using on my machine. So the minimum virtual disk limit that I'm using is 64 gig. The swap is 2 gig. Memory limit is 6 gig. And the CPU limit is 8 gig. All right. Once that is done and you've adjusted your resources, you can apply and restart. So right now, so let's say I adjusted this. You see that apply and restart is enabled. But right now, I'm leaving it at 2 gig. And once you've done that, you apply and restart first. Then you go into your Kubernetes section in here. And then you tab, you check enable Kubernetes. But before you also, once you do that, before you continue, you go into the features and deploy development. If you have something like a Rosetta image on your machine here, you might want to enable it, but I don't have it in here, so it's okay. If you're using the latest Docker versions, you may not have this challenge. And in the experimental features, if you are interested, you can access the experimental features. All right. And I think that will be all. And all you just have to do now is apply and restart. Once you enable Kubernetes, just apply and restart. It takes a few seconds for Kubernetes to get installed on your machine. Once that is done, you go into your dashboard again. You go into the dashboard and you will see something like this on the bottom left corner of your machine, which is Kubernetes is currently running. Okay. And also, if you go in down into your Docker and you click on the Docker icon, you see that Kubernetes is running as well. Now, two things you have to do. The first thing is once Kubernetes is running, up and running, you want to select the context at which Kubernetes will be running, which will be like the engine that is powering your Kubernetes. In this case, we are working with Docker Desktop. So if you select this, you should be good. Now, once that is done, you need another thing to get you forward. All right. So the next thing you want to do is get kubectl installed, or minikube. Okay. Now, once you have installed your Kubernetes and it is working as expected, there is a need for us to interact with the cluster. The easiest way to do that is to use these installed tools. We have the kubectl, which is the Kubernetes command line tools, or you can decide to use the kind. It allows you to also run Kubernetes on your local system as well. You have minikube and you have kubeadm. Now, if you are not using kubectl, you can also use any of these other packages to manage your Kubernetes cluster on your local system. But in this case, we'll be sticking to kubectl. For instance, if you are working with this kubectl on Windows, you can follow this to get it installed on your system. This is the binary instruction for Windows. And once you are done with the installation, you do the validation, which is optional. That's optional really. The major thing is for you to get it installed, and then just check your information with this Kubernetes kubectl version client and all that. But if you are working with Chocolatey, Scoop, or Winget, this is the command you use to do the installation, and after that you do the validation to see that it's working as expected. I mean, just other informations are here for you to work with. Another thing that you can also do is there are some troubleshooting information in case you run into issues or any other messages like no what provider found or something like that. When you are installing your kubectl, you can follow the instruction here to get it restored. Once that is resolved, then you should be good to go. Then if you are working with Linux, you can come into the install and set up kubectl on Linux, and you will see the information that would allow you to get it installed on Linux. And one of them is to get the binary release version, which can be done using curl if you are using the x64-bit or ARM64. Okay. Depending on the version of operating system you are using, you have to be very specific about which one you are selecting in here. Otherwise, you might run into some challenges by the time you finish your installation. So if you are using any other package manager like Debian-based distribution, Red Hat, or SUSE-based, you can copy this command and get it installed. Just follow the instruction in here, and it's actually pretty straightforward. And these are the optional configurations and plugins that you can install, like Bash, ZSH, Fish, and the rest like that. All right. Now, but in my case, I'll be focusing on kubectl on macOS, which is the one that I'm going to be working with in this video. For macOS, of course, there are also different ways of doing that. If you are using the binary release, of course, you have to be very selective of which one you are going to be using. So if you are using the Intel version of operating system and your chip is an Intel chip, you have to use this command for the Intel version. But if you are using the Apple Silicon, you use this command as well. All right, and that said, you have to just follow the rest of this installation process to do the validation, which is optional, totally optional. You don't have to do that, but I mean, this is done, just to move the right things in the right place and all that. But my favorite is to use it with a package manager like Homebrew. Now with this, all the other installations like validation, chmod, copy that, move this, you won't be doing that. What you'll be doing basically is just running this command on your machine. It's either you run this brew ctl kubectl, or you run brew install kubernetes ctl. In my case, if I come into my terminal in here, I already have it installed, so I'm not going to be doing the installation again. I'll just run this command and it should tell me that I already have it installed. So if I copy pasted that into my terminal, and you can see that Homebrew is already installed. I mean, if you want to install Homebrew on your system, you can just Google that, how to install Homebrew on your Mac OS, and you should be good. I mean, this is not the video to do the installations for Homebrew and all that, but this is just to show you the dependency. So if you are using Mac ports anyways, you can use this to do the installation of kubectl with Mac ports. Then you can verify it with this, and if you are trying to troubleshoot any other error messages that you might encounter, you can follow this process in here. For other configurations and plugins, of course, like bash, fish, zsh, I'm using zsh myself, so you might want to follow the same process to get it installed on your machine. Otherwise, you should be good, pretty much straightforward. And on the terminal, if you look at what I have, it is telling me that I already have it installed. It says Kubernetes this and that is already installed and up to date. To reinstall, you have to maybe you rerun this command and you should be good. But I'm not going to be doing that right now. And that's how to install kubectl on your machine. Finally, there's one other thing that you need to install. So you need to go to m.sh. Now, Helm Charts are the Kubernetes package manager. So what happens is, just like you have Homebrew that is housing all different packages that you can work with on your Mac OS, the same thing happens for Helm, but this time is majorly focused for Kubernetes. Okay, so when you are working with Helm, if you want to get it installed, just click on the docs in here and go into the introduction, and then you see the installing Helm in this case. Now, if you're using the binary version, you can get it installed using this, do the download version, unpack it, then do the needful by copying and moving all those stats. But I'm not going to be doing that. I'll be using, like I said, I prefer the package manager in my own case. So I'll be using the brew install Helm. So if I copy this command and go to the terminal and I run this, excuse me, you can see that Helm is already installed on my machine and up to date. All right, so if you're using Windows, you can use this to install using Chocolate. You can use the Choco install this. If you're using Scoop, you can use it with this. APT for Debian Ubuntu, DNF for Yum for Fedora systems. For Snap, you can use the same command in here. For PKG, FreeBSD, and the rest like that, you can use this for your package installation for Helm. But if you want to build from source, you just do the cloning and then do the CMake. But you have to ensure that you have your CMake installed on your machine, and maybe the make version is compatible with this Helm machine. It's M version. Yeah, this is the M version. So right now the version is 3.14. This is the Git commit, the Git tree slate, and then the Go version that is currently running on my system. Once this is done, you are ready to continue with the dashboard. I'm going to clear this up. So if you want to confirm that it's actually installed, the first thing you want to do is kubectl version. Kubectl version is going to give you the client version you're working with, the customized version, as well as the server version. But if you want to see if your commands are working, kubectl, just type in kubectl, and you will see the different commands that you can work with in here. You can see the one to create cluster or file, the one to expose, and the rest of the basic commands and all our cluster management commands. So right now, everything is working as expected. Now, the next thing you want to do is want to see whether your kubectl is connecting to your Kubernetes cluster. The way to do that is to confirm that your Kubernetes cluster is working as expected. How can you do that? There's a command to do that, which is kubectl. Then you do cluster info. Now, cluster info is going to give you the cluster control plane for Kubernetes that is currently running on your machine, and the core DNS. So you have the Kubernetes control plane, which is on this internal port, and the core DNS that you are running on your system is here. Okay, so this gives you access to the Kubernetes core DNS as well as the control plane that you are currently working with. If you want to diagnose or if there's any cluster problem, you can use this command kubectl cluster info dump. We're going to be using a couple of commands in this video, but we're not going to be talking too much about the commands. We're going to stick to a few commands that we're going to be working with. And if you want a full and in-depth section on this Kubernetes you can check Data Mastery Lab. The link is in the description, so you can get started on how to work with Kubernetes for data engineering. All right, so while this is done, the next thing we want to do is get the context that we're currently working with. We already set it earlier, if you can recall. We already set it in here where we have a Kubernetes context as a Docker desktop. But it is possible you have a different cluster you're working with, so you can switch the different clusters you're working with this command. So you can check the cluster you're working with, kubectl config get context. Now this is going to give you the clusters and the context that you currently have on your machine. Right now I have a single cluster. I'm not doing anything too crazy with my system, so right now it's just a single cluster, Docker desktop cluster, and the name of the cluster is Docker desktop. The authentication info is Docker desktop. So if you create a cluster, maybe you create a cluster with kind or kube admin or minikube or any other, even with kubectl, all your clusters will be listed under the get context in here, and you can switch at any point in time. All right, so you can easily switch that to kubectl config and set context, and then you type in the name of the context you want to set. Once this is done, then the context will be modified to that particular cluster. So if you want to switch, you can do that. There are other efficient way of switching the clusters. If you want, you can look at the documentation for that. But we're not going to be going too much into the details of that. So the next thing we want to do is get our pods and deployments and everything ready. But how do we visualize our Kubernetes cluster? Right now, our Kubernetes cluster is running, but we can't see anything. There's nothing to manage on this cluster. We don't even know how the dashboard is looking like and all that. So let's get our dashboard installed and set up. Okay, so to get your dashboard set up, there's a command for that, and this command is going to be leveraging the default configurations that are coming from the Kubernetes team. The Kubernetes team have a dashboard which is called Kubernetes Dashboard, and a YAML file that is containing all of these configurations. I'm going to show you how the configuration look like in a second, and this configuration is going to be where you have all the different pods and deployment and services and how they are connected to each other, including the secrets and all that are going to be connected to them. So let's do that and get our dashboard ready. Okay, I'm going to just type in kubectl apply, and instead of that, I'll be applying the recommended version for Kubernetes. I'll just copy this command so we can inspect what is inside this YAML file before installing it. Now, this is the 2017 versions. This is done by the authors, the Kubernetes team. And you can see the namespace in here, the service account, the service, the secrets, what else? Config map, the roles, permission. This is the role-based access control for this guy. The cluster role binding, cluster role binding, deployment, what else? Service deployments as well. And those are the kind of this is the YAML file that is containing all our configurations. So this can be separated for in production environments. You might want to separate this into separate files and folders, so it's easily to manage them. But in this case, we're just going to be applying this directly. So to apply that, I just do the kubectl apply, then a flag of F, which is where the file is going to be coming from, and the URL for the Kubernetes dashboard. I'm going to leave the dashboard in my GitHub repository. If you check the link in the description, you'll see it there. So once you do this, you have access to the kubectl. Now, all of these have been created. We have a namespace, the service account, the service cluster role binding, and the rest of them. And the role-based access control has been assigned to the default users as well. So the next thing you want to do is create a visualization on the UI. So we use that. You usually do this with port forwarding. Port forwarding forwards the ports that you have on your local machine to the ports on your Kubernetes cluster. So that's the way port forwarding, just like you expose a port on Docker, where you do maybe -p, then, or do you do expose 8080 or any other port, and then it gets exposed on your local machine. So right now, the next thing we want to do is, do a port forwarding to this, and then we can see, we can access the dashboard. All right. So we do that using kubectl port forward, and I'm going to be doing kubectl proxy, so we can access the dashboard, and then we are serving this on 8001. And if you go to my local host 8001, just this alone, 8001, you can see that I have access to all of this, and these are the paths that I can work with. And if I just go to the API version 1 namespace and all that, and I go into this URL in full, now the URL in full is this. I think I can open a new tab in here and just paste that there so you can see the full URL. This is the full URL, the local host 8001, API version 1 namespace, Kubernetes Dashboard. Then I'm calling the services with this Kubernetes Dashboard for my proxy. Okay. Once that is done, I have the URL in here. Now, the next thing for us to do is to get our token. Now, token can be two types of token can be worked with in here. You can use the short-lived version of the token, and you can use a long-lived version, more like the duration. It's just the duration of the token lifespan that is different. All right. In this case, we are going to be creating our secret that we can work with. Now, let's generate our token. To do that, I'm going to create a new small project where I'm going to be keeping all the files and the configurations that I'll be working with in this video. And that will also serve as the repository where I'm going to be putting all of this data into. All right. So let's do that by creating a new project. I'll open my PyCharm just in case. You can use any IDE, VS Code, or any other IDEs that you like, but I'll be using PyCharm in my case. All right. So for PyCharm, I'll just open this in here and call this Kubernetes for data engineering. In fact, I'll type it in full, Kubernetes for data engineering, and I don't need to create any Python main.py welcome scripts. I'll just leave it at that. And the next thing is to just create, and that would be created in here, so we can get our files ready and all our codes written out. All right, so while this is going on, I'm going to open up a terminal that I'm going to be working with. And it takes a few seconds for the initialization to be done, but once it is done, we are ready to get started. Let me just try to increase this a little bit. And I have a bigger version. Okay, so let's create our first. In a production environment, you want to ensure that your user is properly given the right permission and is not given maybe the root privileges and all. But in this case, we're just going to be using the admin user to have all the privileges or the root privileges. Okay, super user privileges, of course. So we're going to start with the admin user or the service account. I'm just going to say touch dashboard, and that will be my admin user. I'm going to be creating the admin user, and inside the admin user, I'll put in the configuration, the YAML configuration that is going to be linking to my namespace and creating a service account for me. I'm going to have my first API version. It's going to be version 1. And the kind of resource that I'm creating is a service account. And the metadata, in this case, is going to be the admin user metadata. And the name is going to be the admin user. And which namespace am I creating this? It's going to be in the Kubernetes dashboard. All right. Now, once this is done, potentially our service account is created with the admin user. We have not created it yet. I mean, just potentially. We are assuming that this is going to be created. And the next thing we want to do is get the role that is going to be accessible to this particular admin user. So inside the dashboard cluster role, we're going to have our cluster role definitions, which is going to be the YAML that we're going to be working with. I'm going to have the API version. API version is going to be coming from role-based access control, RBAC authorization.kubernetes.io/version 1. All right. The kind of resource is going to be cluster role binding. And the metadata that is attached to that is going to be the name, is going to be the admin user. And the role reference is going to be the API group, the kind, as well as the name. So I'm going to have the RBAC, just like I had at the top in the authorization.kubernetes.io/version 1. All right. The kind of resource is going to be cluster role binding. And the metadata that is attached to that is going to be the name, is going to be the admin user. And the role reference is going to be the API group, the kind, as well as the name. So I'm going to have the cluster.kubernetes.io, and then the kind is going to be cluster role. Then the name is going to be cluster admin. So this will be the manager of the cluster itself. Then the subjects, this is where we are applying this to. I mean, the resource we're applying it to. This is the service account. I'm applying it on the service account kind. And then the admin, the name is going to be the admin user. And then the namespace that this is going to be sitting in is the Kubernetes dashboard. Now, once this is done, the next thing is to get in our final thing, which is going to be our secret, where everything is going to be used to generate a token for us. So I'm going to have I'm going to create a new file. I'll call this secret.yaml, and inside our secret.yaml, I'm going to have an API version. In this case, version 1. The kind is going to be secret, and the metadata is going to be the name is going to be admin user. Yeah. Then the namespace is going to be Kubernetes dashboard. Then the annotations, which is going to be more like what you are leveraging on. I'm going to have the Kubernetes.io/service accounts, service.account .name. All right, so I'm getting the Kubernetes.io service accounts.name, and I'm going to be assigning the admin user to that. And finally, I'm going to be working with a type, which is the type of resource. It's going to be Kubernetes.io/service account/token. All right, so that would be more like the output that is generated from there. All right. Once this is done, I think we are ready to apply these three, and we can use this to generate our token to our cluster. So the first thing we want to do is ensure that our cluster is still running and everything is working as expected. Then we can apply that. Before we apply the changes, let's look at the dashboard, just like these changes that we've just created. On the dashboard, we are still being asked for our token. So let's apply that and see if we can generate our token from there. So I'm going to have our dashboard. So I'm going to do kubectl, ctl, apply. And I'm going to start with the admin user. Once I do that, it's going to create a service account called admin user in the same namespace. Then I'm going to go ahead and create the cluster role. And I have my cluster role created now. And for my secret as well, I'm going to create that. So the three resources have been created. Now let's generate a token from this secret. So I'm going to have my kubectl get secret, and I'm going to be getting that from the admin user, get secret admin user that I created just now, this one. And the namespace is going to be Kubernetes dashboard, and the JSON path is going to be the output. This is the dashboard, then the JSON part is going to be this is what I'm going to be extracting from there, .data.token, and I'm going to be doing that using the pipe function of base64-d. All right. Now this generated the token for me, and if you look at the token in here, it's like this. All right, I just need to copy this token now, but be careful of this percentage at the end. So you don't want to copy the percentage. You copy that without the percentage, otherwise you see an error on the UI. Okay, so if I paste the token in here and I press sign in, I'm able to access my dashboard. Right now I have a couple of dashboards and namespaces in here, but right now this is how the dashboard looks like, and then how we can access it. And these are the kind of ports that is powering this Kubernetes dashboard that we're working with, that is giving us access to review everything on the workload that we're working with in this video. Now let's go through these everything we have on our UI and see what we can make sense of these things. In this UI, you have the Kubernetes dashboard UI, where you have all of the workloads and all the essential information about your cluster are listed in. So let's start with the one at the top in here. We have all the namespaces in here. In this case, we have the namespaces that have been created using the script that you used earlier. These are the namespaces that have been created. So these are more like the different buckets of the services that you have in your cluster. Okay, and you can search for any of the services in here. And for the plus, you can use this to create any file. In this case, maybe you want to create a new Kubernetes resource directly from this dashboard. You can do that. And you can also use this to deploy maybe a new application. You can use it to create services, etc. Maybe you are using from file, from input, or any other one, any other places you want to, create data from. That's what you use that for. And then this bell is for the notifications, and this is where you manage your profile. All right, you see your profile that you are logged in with, and you can sign out from there. Now, the next thing is the workloads. The workloads gives you access to the deployment, the replica set, the stateful set, the daemon sets, and all that. All right, all those are the basic details about your workload. So right now we don't have any cron jobs running and no daemon sets. We have one daemon set, which is our kube proxy, and that was enabled when we use our kubectl proxy earlier that we were working with, that is powering this dashboard, the daemon that is powering this dashboard. Then we have the deployments. This is the different deployments that you have, more like the services that is holding each of these buckets. We have currently we have the dashboard metrics scraper, core DNS, and the Kubernetes dashboard in there. Then for the jobs and pods, so the jobs are the maybe currently running jobs and all that on your pods, but the pods are more like the detailed view of the current running pods. You can see the status of the pods. Whether this is more like your container if you are working with Docker in this case. This is a container, like a running application. So this can be teared down or spin up in real time as the need arises. So you can see the status and the logs and the basic details for these pods that you're currently working with. All right. In this case, you also have something like a replica set, which is more like the replications that is available for your services. So when one pod goes down, maybe you are maintaining 3 replica sets, for instance. If your pod goes down and then you have 2 pods left, another one will be spin up in its place and to replace the one that went down. Then we have the replication controller. Nothing is here right now. We have the stateful sets and the rest. And then in the services, we have the services that are currently running in the system. The services, this usually defines how to access the application. When maybe you're accessing it through load balancer or through a node port. You can do that in here. Then we have the ingresses and the classes. This is the services. You can see that I'm using the cluster IP to access this, and you can also use the node ports, or you are using the load balancer. Anyhow, to access the system. We have the ingresses, and which is where you usually control the traffic into the system, just like you do in your load balancer. And then we have the config and storage. Inside the config and storage, this is where you usually have the config maps, the secrets, the persistent volume claims. So for the config maps and the secrets, they are usually used for the configuration of data and sensitive information, while the PVC, the persistent volume claim, is used for managing the storage volumes. All right. And then the next one we want to talk about is the namespaces. Where is it? Yeah, under the cluster. So under the cluster, you see the cluster role bindings, which are the users that you create, and you assign a role to them. More like we are working with a role-based access control now. So we have a cluster role binding, which is binded to a particular cluster role, and which in turn is inside a namespace. And these are the nodes that we are currently working with. So these are the role bindings, the roles, and the service accounts. Okay? So those are that's just maybe the basic information that you can get from there. And then you have the custom resource definition, if there's any, and these are the settings, the name of your cluster, then the default namespace that you want to be seeing when you start your cluster up, and this is the information about your dashboard. I hope I've been able to a little bit tell you some information about this dashboard. But if you want more information, you can either go to datamasterylab.com. You see more information in there, or you go into the official documentation and then look up each individual details up for more information. Now, once we have our dashboard, the next thing we want to do is dive into properly how we can apply these Kubernetes clusters to our data engineering endeavor. Now, in this case, we are going to be working with Apache Airflow. Apache Airflow is of course, an orchestration software, which is no longer news. But in case you want to work with Kubernetes, it takes a few adjustments here and there for you to properly set it up, just like you would on a normal system, or you are using maybe Apache Airflow in a normal, maybe you are setting it up in a normal system, just like doing your normal pip install. But in our case here, we are going to be running Apache Airflow on multiple pods and multiple clusters on this Kubernetes cluster. Now, once any of these pods goes down, another one will be replacing it in its place and then spin up to work in its place. All right, so let's see how that goes and how we work with that. So going back to our dashboard. On the dashboard, we have all the workload set up. Now, don't forget, I was talking about Helm the other time, and if you haven't gotten it installed already, you want to do that. And let's see section, okay? Now, if you go to the Helm version, you see the version of Helm that is currently working on your system. And if you type in Helm, you see all the details that you currently have and the available commands that you can work with Helm. Now, in our case, you see the default directly. In our case here, I'm just going to go into the Helm information and we just get it right from there. Now, going from here, you can either come in here and type in Helm install, and then you have your namespace installed directly. Just like this, you say Helm installed Airflow, and then the name of the package, which is Apache Airflow /Airflow. And the namespace you are working with is the Airflow namespace. There's no need to separately create the namespace. You can just do -- create namespace, and this will automatically create the namespace for you. I added this debug flag so we can see the individual step that is used to create this Apache Airflow for us. But this is an optional case. You don't have to do this thing, the -- debug. Once the debug flag has been added, you'll be able to see the process listed one after the other, and the steps taken to get the Apache Airflow installed on your Kubernetes cluster will be listed. So I'll just run that and let's see how that looks like. Now we have a job that is currently running in here. You can see jobs active 1 in here, and you can see that all these are getting running on the UI. So if you go to the Airflow namespace that has been created, once you started that, you see that there is a job currently called Airflow migrations that is currently running on your machine. Okay, once that is done, you also preview that on the terminal as well. So if there's any other job that is currently running from your cluster on your cluster, you will see them in here. Okay, and there's another one that is currently started, which is Airflow create user, and that is the latest one that is added to this list. This one, Airflow create user, and this is currently active. It has not been modified or failed. Okay, now once these two are done, I think that should probably fix whatever issue that is left with Apache Airflow getting started. We just wait a few more seconds for these installations to be done. Now on the Docker desktop dashboard, you can see everything that is currently running. Meanwhile, if you adjust your container CPU usage and all that, I adjusted mine from the initial one. I just thought that should be shared with you. If you look at the resources, I reduced it from 8 to 4, memory limit to 4, swap to 2, and 64 gig virtual disk limit, just in case you want to update that much later. It's okay, but if you have enough resources to handle heavy workloads, you can increase it as well. but I think that should work fine. Okay. Now this is the services that are currently running on my cluster, and interestingly you can see that Apache Airflow is done, and just before this is completed you will see the configuration that was used to configure the Apache Airflow on the Kubernetes cluster. Those YAML files and configuration files that were used, and you can see the computed values that were used in here, and these are the details of all of them. Something like the DAGs processor is here. You have the DAGs in here, the persistence, the data is here, Elasticsearch as well, then broker as well. The executor is Celery executor. We are going to update and override this shortly. And let's see any other thing. Just a lot of things you can. All of this can be overwritten, and you can change the values in there if you are not comfortable with that, or you want to change the configurations for some reasons. Now to do that, we can do a port forwarding to see the current implementation of our kubectl, of our Apache Airflow. Okay, if you run this, it is now forwarding requests from our local host 8080 to the ports 8080, and also from our IP version 6, I guess, to 8080 as well. So if you go here and then on the local host 8080 there, and I think it's still waiting for connection. Yeah, connection refused. Why is that? Is our web server ready? Our kubectl get ports Airflow. Let's see. Yeah. Okay. So there's an error with the web server in here. It's restarted 2 times. I don't know why exactly, but let's see what that looks like on the UI. So if you go to the workloads in here and you do a refresh, yeah, I think the ports are working fine now. The replica sets are okay, and then the stateful sets are fine, and the deployments also, everything is working as expected. So if you do a port forwarding again, and we go to the UI and do a refresh, it should be good. Yeah, perfect. I think it's fine now. We can do admin. I guess we started that way faster than it is ready to accept connections. Okay. Interestingly, we see a warning message here, which is the usage of dynamic web server secret key detected. We should use a static web server secret key. All right, that's an interesting one. So let's override this and fix this error. Well, not an error, warning message. So going back to our code in here to see the values that we saw when we were doing the installation, we need to use a command from Helm to get all this configuration. So we can do Helm show values, and this is going to dump the values into our values.yaml file. So it's just show values for this image that we're currently using, and dump it into the values.yaml. Now you can either use this or download the values.yaml on the website. Well, I think if you want to go through the shortcuts of doing things beforehand, that works fine, but it doesn't hurt if you did something like this, just to do a dump of that particular configuration, and then upgrade and override those values anytime you want. Okay, so you can do that, or you can get the values.yaml beforehand and just override it once and for all. Okay. Now just delete everything in there. You don't have to, but just like we had in the terminal, everything is here. And for some reasons, if you are looking for DAGs, you see the DAGs in here, the persistence, all this information that were in the terminal earlier that we're talking about. Well, that works fine. So, but I'm going to just delete everything and just pinpoint a couple of keys that I'll be overriding. All right. So the first one that I'll be overriding is the Fairnet key, and the other one is the web server secret key. Now these two are the ones that I'm more particular about to override for now. To get the values that I'm going to be using to override this, you can either use a base64 encoded format of this secret key, or you use the finite key that is generated when you created your Apache Airflow, something like this. You can get the finite key here by running this command. If you copy this command and you come to your terminal and paste this, you can see the Fairnet key in here. So you can copy this Fairnet key and paste it as your server, both finite key and the web server secret key. Like I said, you can also use the Python generated or base64 encoded secret key as well. Any of them works fine, just fine. Okay. Now, the next thing we want to override this time is the executor. The executor that is by default added to the system is the Celery executor. Let's change that to Kubernetes executor. All right. Kubernetes executor. And those are the three values that I will be overwriting for now. We're going to override more, but let's stick to these three for now. So let's upgrade that and apply that. To do the application, instead of the installation, we are going to go for the upgrade. And now we are going to add an install flag for the namespace here, Airflow name, and the image name, then the namespace, dash namespace. It's like this, dash namespace, Airflow, create namespace. This is optional, you don't have to add this, but we are going to be adding the value, overriding the values.yaml. The values inside this, the key values inside this values.yaml will be used to override the configuration, if that makes sense. Okay. So if I run this again, it takes a few seconds for the override to be completed. I'll just wait for a few seconds for this to be done. And after this is applied and the configuration is updated, you will see that the dynamic server web server secret key error warning message that we have here will be gone. So we just wait a few more seconds for that to be done, and then we continue. Now, this is how it looks like once it has been applied and there is updating the changes. Okay, so the same thing that you were shown the other time, but this time around, the release has been upgraded. Okay, now this time we can still do a port forwarding. I'll just leave it at this as it is. And if you look at the this is our kubectl, and this is our proxy. It's still handling connection. Is okay. I just need to do a refresh in here. And let's see if the warning message is gone. Okay, so it's still not working. Why is that? Yeah, it lost connection to the port. So let's see if on the UI, if the ports are running and they are healthy. All right, we have 5 running ports. I think replica set is still working. Let's see, everything should be fine. We have our web server in the replica set. In the ports, is our web server working as expected? Yeah, I think so. So I think we just need to re-forward the port forwarding again, and then we can check it again on the UI. Yeah, perfect. So it's okay now. I just do admin to log in again, and right now you can see the warning message gone. Now the cluster activity as well has been updated, and you can see that the scheduler triggerer, everything is working as expected, and they are healthy. Perfect. So now let's show our what's the name, the DAGs on the UI. So we don't have any DAG right now. I'm just going to create a new DAG for us to work with. All right, so now going back to the code, we have a folder called DAGs in here. I think I did that offline. I just created a new folder called DAGs. And once you've created that, you can create a new file called hello inside the DAGs. So that's where we are going to be having our DAGs file in here. And if you don't have Git initialized before, we just do Git init. So we can initialize the Git into your current directory. All right, so we have our DAGs in here that is going to be holding the DAGs. So just need to install Apache Airflow just so we can resolve all the syntax errors and we don't see errors everywhere. Okay, and once this is done, we come to the DAG in here. We have from our Airflow import DAG, and then from Airflow operators.bash import bash operator, because that's the one we just want to display hello world and hello data mastery lab from there, and we just need the date time as well. Import date time, and then time delta. And then we have our default arguments that we're going to be working with, which is the owner is the data mastery lab. We have our start date, and the start date is date time that we already imported. If you haven't imported that, you can do the import here, and this will be 25, and the catch up will be false, just in case you missed a day. If you enable catch up, it's going to run the backfill of the previous day that you missed. Okay, but we don't want that. Just a simple package that we just want to run. We have our DAG IDs as hello world. We have our default arguments. Default args is going to be default args. Okay, and the schedule is going to be the schedule. It was previously scheduled interval, but there's an upgrade on that. So we have schedule now, and the schedule is going to be time delta that we imported, and the days is going to be 1. Now, just in case you use the schedule interval, it's still going to work fine, but it's going to be removed in the later versions of DAG. Okay. Now let's get in our tasks. We have our task 1. Just in case, if you are interested in going further into Apache Airflow, you can check datamasterylab.com for more information, or you check the channel. You see a lot of Apache Airflow related videos that you can watch and get you started on Apache Airflow and how it works and all that. Okay, just putting that out there just in case you need it. We have our bash operator, and we're going to have a task ID as a hello world. Hello world, yeah. If I can only type hello world. And we have our bash command is going to be echo hello world, and the DAG that this is going to be attached to is going to be our DAG. Okay, now the second task is just going to be a replica of this. I'll just copy this and duplicate the process, and then task 2, but instead of hello world, we change this to hello DML, and we have hello data mastery lab. Okay, and once this is done, the next thing is just to set the upstream or the downstream. So we have T1 is going to be the upstream for T2, or T2 is the downstream of T1, whichever way you put it. All right, once this is done, we're good, and I think we should just change this to datamasterylab.com, and we should be good right now. Now, the next thing for us is to get our repository that we're going to be linking this to. So there are 2 ways to that. You can either link from your local system or to the repository. I feel the repository is more is better, and it gives you access to do some version controlling, and you can easily control the branches and all that, even though you can do it locally. But what's stopping you from linking it to your repository? Okay, let's do that with our repository. So I just created a new repository. I'll just copy that link in there, and here I'm just going to set my origin, git remote, add origin, origin, and I'm going to be setting the origin to Kubernetes for data engineering. And once the remote origin is set, I can easily just get my DAGs added to the list, and I can commit that GST, and you can see my status. This is the DAGs, the LOPY that I'm staging for commit. I just do GC message and then LO DAG script, simple as that, and just push this GGP. And once that is pushed, if you check my repository, you see this. You can use the same link as well, but you can't push to it, of course. You might want to use the same code, but inside your repository, so you can push to it. But you can create a PR if you want. It's okay. I can always review it, and if it is something that I'm interested in changing, we can always review that and change it. Okay. Now, once this is done, we've pushed our code to our repository, and we can easily access what we have on the repository, just like this. If you go to Kubernetes for data engineering, you can see that I just have my scripts in here, and just here I have my hello.py DAG script, and this is everything that I wrote in here for T1 and T2, and that is okay. The next thing is just to connect our repository with our Kubernetes that is currently running our Apache Airflow. Okay, so we can see our DAG in here. Now, easily, just like we did before, we can come back to our values in here. In the values.yaml, that is where we're going to be writing the script that is going to be overriding the repository URL. So I'm going to have my DAGs in here, and I'm going to be overwriting the git sync of this DAG, I'm going to be enabling this enable is going to be true. So to enable the Git synchronization, and the repository link is going to be this one. Don't forget, you need to add .git at the end of the day. Once that is done, you get in your branch that you're looking for. In my case, I'll be looking for the where is it? Yeah, the main branch. Okay, just the main branch is fine. Main branch, which is main. Then the revision is the head, of course, the latest commit, and the depth is 1. This is optional. Max failures is just in case it fails, is 0. And of course, the sub path, which is very important. So this is where the DAGs are located. And in my case, DAGs are located in the DAGs folder. All right, so that's where you have your sub path. In a case where you have this inside another folder, you can do maybe Airflow. Maybe this is your structure. You have Airflow DAGs, and then you have DAGs, something like this. That means this DAGs is a subdirectory inside Airflow DAGs. Then you have to do something like that. And if it is in a multiple layer, you can do the / as well. So I'll just leave it as it is. And that will be DAGs. Okay. And that should, that's all we need. Now, in a case where you are working with a private repository and you need to link the Kubernetes on your cluster with some SSH keys or some keys, whatever it is, you have to first configure that with the SSH key inside this DAGs. There's a part where you can do that. You can check the values.yaml, the full values.yaml that you exported from Helms. You'll see the part where you can update the SSH keys there, or if you're using a private key or whatever other keys that you're using to access your repository, or even if it is username and password, you can use that as well. It's not recommended, but if you use that, you can always use that particular whatever it is you access your repository with. You can use it to configure your Git repository sync. But in this case, we're just going to be going for a public repository that is available to everybody, and you can always use the DAGs in here as many times as possible. Okay, now that is done, the next thing is for us to override this value. I hope you can still recall how we did that. Let's do that again. Just the same command, upgrade, the same blah blah blah. Then we have the -f values.yaml, and this takes a few seconds to be applied. And once it is applied on the UI, once it is applied, you will see that our sync, our Kubernetes cluster is going to automatically synchronize with our GitHub repository. And by the time we had a new DAG or you change anything in the code, everything will be updated as required. Okay, so let's just wait a few seconds for this to be done, and we continue from there. All right, so the application has been done, and right now the configuration has been updated. And what we have, let's see on the UI if everything is working as expected. Yeah, we just do a refresh in here. Yeah, our token has expired, so let's get a new token. kubectl get secrets for the admin user in this namespace of Kubernetes Dashboard, and get the JSON part data.token. Don't forget, don't copy the percentage at the end, just copy before the percentage and paste that in there, and you should be good. Now in the Airflow, it still say 1 is failing, and we have 5 running. So if I do a refresh again, one of our replica sets, one is failing in our deployment, and our pods as well. But let's see, our web server is still not working as expected. Let's see what is going on with it. Okay, it has been corrected and it should be good now. Let's look at our workflow. Well, it's still running. Well, regardless of that, I'm just going to go into the I'll just do our handling of connection again for the port forwarding for Apache Airflow, and let's see what that looks like on the UI. Okay, do we have any error message? No error message. Okay, so it's working, and we just did a refresh. Perfect. And you can see we have a perfecto. Owner is datamasterlab.com, and we have hello world in here that is ready to be triggered and run. Okay, easily. If you go into the hello world, you click on the hello world in there. It allows us to go in there. You have hello world, hello DML. If you look at the code that we have in here, this is the same thing that we had, hello world, hello DML. Okay, perfect. So let's run this and see how it looks like. I'll just unpause that and let's see how that looks like once it is triggered. I'll just go to the DAGs and do we have anyone running? Okay, not yet. It just enabled. I'll just trigger that. And let's see how that looks like once it is running. Hello world is currently running, and interestingly, yeah, it has finished running, and it's running hello DML as well. Hello world. If I click on this green button and I go to the logs, it's still not serving the name. This will be corrected shortly, and we just wait a few more seconds for this to be done. Do we have any errors? Okay, and let's see. Okay, name of service not known. It's okay. This will be fixed shortly, and I just need to. These two are working as expected. Our DAG is triggering, and we can, run it as a to completion without any errors. That's a good thing. Now let's now do a little bit more serious talk. Okay, something a little bit more serious. If you go to the code again. Now, this time around, we are going to be doing a couple of things to get data from online and then preview what the content looks like. So I have one of my repository called Apache Flink Sales Analytics. I have one CSV in there. I'll just use that as our reference in this case. So let's create a new DAG to show that we have our DAGs and then we have our fetch and preview. I'll just call that fetch and preview if that's okay. Now, inside our fetch and preview, what we want to do basically is to get data from this URL. It's a CSV, all right, without an header. So what we're going to be doing, we are going to read this CSV, attach an header to that, and then, just preview that. That's the simplest thing we want to do in this video. We can do something more complex, of course, if your use case is a little bit more complex than mine. But my use case is just to get this CSV without header, attach an header to that, read it, and then display or dump it to my terminal. That's all I need to do. So I'll just get in my my DAG. I'll just do my import from Airflow, import DAG. And then from airflow.operators, I'll be using the Python this time around, the Python operator, operator. All right. And I'll be needing requests because I'll be getting the request from my GitHub URL. So I'll just copy the URL so I can paste it in here. So I'll be needing the request, import request. If only I can type request. Okay. So I'll just get two functions. One to get the data. So for getting the data, I have my get data, and I get in the quacks or all the arguments that will be passed into this function. The URL that I'll be working with is going to be this URL. So this is the URL where I stored my CSV. I call this CSV new output. So you can check it out in my repository if you want to look at the structure. Or we can also copy that and on the URL to see the structure and how it looks like. This is it. So we have electronics. This is the category. This is the price, and this is the quantity. Okay. So we can work with that. If you have something more complex, of course, you can use that as well. It works fine. So I have my response in this case to get request or get, so I can get the URL. Okay, so that means I'm doing a request to this URL to fetch that data. And if my request dot status code equals to what am I doing? Response dot status code equals 200. If my response status code is 200, I'm going to be putting this in my panda. So let's get pandas into the picture. pandas, import pandas as PD. And I just do pip install pandas, okay? And just getting pandas in here, I'll just get that into my data frame, pd.read CSV, and that will be from the URL, okay? Yeah, I'll just read from the URL, and I'm not going to be reading any header, so the header is going to be none, and the names is going to be the name of the column names is going to be category, and the next thing will be price, of course, and then the quantity. Yeah, those are the column names for each of the data. I just need to do a conversion. What am I doing? Yeah, convert data frame to JSON, a string. All right. The reason why I'm doing this is because I want to pass this as separate task on my Apache Airflow, and by separating them, there's something called XCOM that I'm going to be using to hold my temp values or the outputs of each of the processing temporarily. I'll be pushing the data to XCOM, and I'll be reading from there as well. All right, so going back to the code, this is essentially for XCOM, okay? So I just get my JSON data. Data is going to be df.to.json. And once I do to JSON, I'm going to specify the orientation. The orient is going to be records. All right. And once this is done, the next thing is to push this to my XCOM. The easiest way to do that is to use the quarks. The quarks that are passing as my entry points in there to pass into the task ID, TI, and then after TI. Once I extract that, I do XCOM underscore push. Then I push it to the key of data. What am I doing? Yeah, key equals to data, and the value is going to be JSON underscore data. And what if there is an error and I'm not able to read the URL? I just raise an exception. Simple as that. I'll just call this failed to get. So the exception that I'm going to be adding to that is just to signify that I'll just minimize this and just say failed to get data. Well, I'll just get in the HTTP status code. HTTP status code. If that's okay, just put that in here. Response.status underscore code. Okay, just nothing too serious in there. All right, this is not get date, it's get data. Now I just need to get in my default arguments as before, blah blah blah, and all that. So I think I'll just do a copy of that. Okay, I'll just copy this and copy the DAG as well, and just paste that. Yeah, it's replicated, and inside of the hello world this time around, I'll change the name of the DAG to maybe fetch and preview. That's just what I'm doing with that. And let's get in time and date import this name from date time, and the same thing for time delta as well. And once these are done, we have our get data, which is going to be a Python operator that we just imported. The task ID is going to be get data. Maybe I'll change the name to get data from URL, just so we don't have a clash of the name or with the task ID, just in case, because there are some issues that could arise when you have your task ID name as the name of your variable. All right. We have get data as my Python callable, and the DAG is going to be assigned to DAG. Okay, so that is visible from there. And maybe I'll just have another one, preview data, which is going to be from maybe, I don't know, I don't even know what to type in there, maybe from URL. I'll just put it at that. It can be anything else, but I don't want it to be the same name as my task ID. Okay, my task ID is going to be preview underscore data. Okay, I just don't want the same name. But you can put the same name. This is not going to cause any challenge at this point, but you know, in the long run, it's possible to have a challenge. So I'm going to have a function called preview data. And then I'll just get this assigned to my DAG, okay? DAG equals to DAG, simple as that. And finally, let's get in our function to preview the data as we talked about. Now let's create a function to do that, our preview function. So I'll just have my dev preview data function, and I'll pass in the quarks, okay? Quarks. Just in case, I just realized something. In the previous versions, you see something like provide context is true. This has been deprecated. So just in case you didn't see me do that, that's the reason why it has been deprecated. You can check the documentation for more information on that. So we are going to have our output data that is extracting data from our quarks, okay? So we are going to have quarks and get data from the task ID, TI, and do scompool this time. We're going to be doing scompool from our key. The key is going to be data, and the task IDs is going to be get data. Just in case we are not doing anything more than that for now, we just print the output data if you are interested in that. And if there's an output, then we try to load the output data equals to JSON.loads. Okay, we are trying to load that because we dump it as to JSON earlier before. So let's load it back from JSON. All right, output data. So once we load this, we have our JSON loaded into output data. But if there's no output data, we just raise a value error, and we call this no data received from XCOM. Okay, now once this is done, the next thing is for us to create a data frame for our JSON data frame for from the JSON data. Okay, easily we can have df equals to pd.dataframe. This is pandas 101 class, just in case. We just read that, and then now just a simple thing that we want to do to do a little bit of transformation, and there we have compute total sales. We just do df total is equals to df price, and multiply by df is multiplied by df, and then we are multiply the quantity, quantity. All right, now easily this gives us the total as our total sales. Once we multiply the price and quantity, I'll get the total sales. Then the next thing is just to do a group by based on our use case. We have the group by the category. All right, and then the index is going to be index is going to be false, and then we just do an aggregation, simple aggregation on the quantity of sum as well as the total. Okay, so the quantity is going to be sum, the sum aggregation, while the total as well is going to be sum aggregation. Now for us to sort, we just want to do one final thing in here to sort by total sales. That's the last thing we are doing, just in case you are wondering how long this is going to take. We have sort values. We're going to be sorting by the total. All right, and then the ascending is going to be false. Then we just do a print. If you do a print, and then we print the category and the total, and then we do just print the first 20 records in there. We do add 20, and that's all we just have to do. And you can do more stuff if you want, but for now we just leave it at that. Yeah, that's all we just have to do. df category, that's all, and then we link that to our default arguments, our preview data. Then we just need to set the uplink and the upstream rather and the downstream. So we get our get data is going to be preview data. So once you get the data from the URL, we do a preview of that data from the URL, get data from URL. Perfect. And that's all we have to do. Now, for this to reflect on our Kubernetes cluster, we just have to commit this, git commit, git gst, git status, of course. I'll just do git add DAGs and if you look at this, I have my git status in here, fetch and preview, that has been staged for commit, and just commit that and added, let's say this is a feature, added fetch and preview DAG, maybe capital D. DAG. All right. Once this is done, the next thing is to push this to our repository. Once we push it, we can go to our Apache Airflow now, running our Kubernetes, and do a refresh. It's going to take a few seconds for it to reflect, but it's going to reflect eventually. Just a couple of more seconds to do another refresh. Refresh again. I'll just keep refreshing. Well, let's double check that this is reflecting on our Kubernetes for data engineering. In our DAGs, do we have the data there? Fetch and preview, good. And we just do a refresh again. This is still not showing, and it should show. We just wait a few more seconds. I don't know how long this is going to take, but we just do a refresh, there. Now you can see that this is showing. Once we just do a refresh, our fetch and preview is now showing, and it has not been run before, and the schedule is 1 day at 000. It's okay. We just enable this. Once we enable this, our fetch and preview, you can look at what the content looks like. And if you get data, if you look at the code, this is the code, and it's doing all of this stuff, printing the output here and all that. And that's exactly what we wrote in there. So let's run this and see if everything is working as expected. Okay. Now we just triggered that. It takes a few seconds to be done. And let's look at the graph. The graph is connected. So our get data is as connected as the upstream for preview data. Okay, that's fine. I can work with that. And this is currently running. It has been queued up on our Kubernetes cluster. So get data is working, and it has successfully finished running. Our preview data is queued up on the Kubernetes cluster to be previewed. And let's look at the logs. Name of service not known. Actually, this should be automatically fixed, but let's see why it is not doing that right now. Are we able to preview that? Well, the tool is working as expected, but it's still not previewing that. Let's see why that is the case. Okay. This other one as well is still not working. LODML award could not read serve log. Yeah, I think we should just fix this. Let's find a way to fix this, the preview of the logs, and we should be good afterwards. Okay, and let's see. Before we go, let's look at the XCOM. If you look at the XCOM that we have in here, and if it is getting saved into our XCOM, let's look at that. And you can see what we have in our XCOM. So our data, this is the data that is being sent from get data. Once we are done with the preview, fetch and preview under the get data, this is the data that is sent into our data as our key, and the value is this. So if it is more than this, you see a lot more than that on the XCOM. Okay. So going back to our dashboard, we already have one successful run now. I just did a refresh, and I'm seeing this error message, DAG import errors. And this is one of the error messages that is a little bit, that can give you a little bit of concern, when working with Apache Airflow. The reason for this is simply because of the way I'm importing the packages that I'm working with. If you notice that I'm working with a pandas and request and JSON and the rest here, if I'm not using all of this everywhere, I think it only makes sense to put them somewhere like this. So I can just, only where I'm using them, that's where I do the import, something like this. And the same thing happens here. I can just do import PD as well here, just to do an update to that. And that should resolve it, and we should have a lesser time when it comes to, I think I just moved this JSON as well. I'm going to move it into here, into my preview, and we should be good. I'm just going to commit this again and push. Yeah, I'll commit this and push it again. GA DAGs, and clear this up, GC message, and just push that. It's going to take a few more seconds for it to reflect, and we just wait a few seconds for that to be done. If you get check the repository in here, you will see the update. Has it been applied? Okay, yes, it has. Good. So let's see what we are looking at in this case. If I do a refresh, that should be fixed. Yeah, we are seeing an error. I just forward kubectl port forward. I'll just re-forward the port from 8080 again, and then try to run that. Do we have any error message on our dashboard? The token has expired. Okay, so let's get a new token. kubectl get secret. I'll just copy this. And this is why we might want to think of a long-lived token when we are working with this Kubernetes dashboard, so we don't have to keep regenerating the token every now and then. Oh my God, a lot of them have been crashing. And maybe we just wait a few more seconds for this to be done with. I mean, for all of them to be up and running again. And then we retry. Just refresh. Just in the background, I noticed that the logs wasn't working. So what I did was basically to just do a restart of my Apache Airflow and rerun this again. Interestingly, when I rerun that and if I rerun this again, I was able to preview the logs. Okay, if you just click on Hello World again, all right, if you run this again and you see Hello World is running and you click on the Hello World, in this case, if you go to the logs, all right, if you go to the click on the logs this time around, you can see we have Hello World. Then for the Hello DML as well, we just wait a few seconds for that to be done too. We click on the Hello DML and we should be able to see Hello Data Mastery Lab. Perfect. So if you go to the DAGs again in the home section and you click on fetch and preview, if I run trigger this process again, of course the code is still the same thing. I didn't change the code. I just did a restart of my Apache Airflow cluster, and you are able to see this to do the management of the imports, as well as the where's the second one? This is for preview, and this is for getting the data. Okay, the two has been done, running to completion now. If I click on this and I click on the logs, you will see that nothing is here really, because we just ran it and we are not returning anything. But in the preview data, that's where the data exactly is sitting. Okay, you can see the category and total, which is what we are printing out, and we have the electronics and this and that sorted in descending order. And that's exactly what the mission of this video is about. Now, this is where we are going to be stopping the video for today. Now, you don't have to stop here. There are still other things you can do. There are a lot of more complex processes you can incorporate into your Kubernetes cluster with Apache Airflow. So we are planning to have a different series where we work with maybe Apache Spark, where we're going to be deploying our cluster on the Kubernetes cluster, our Spark cluster and the Kubernetes cluster. And maybe we can also do some other real-time streamings and all that with Kubernetes as well. So stay tuned for that video. And don't forget, if you are new here and you have not subscribed to the channel, don't forget, if you are new here and you have not subscribed to the channel, click on the subscribe button now, as well as like and comment any feedback you have. I'll be more than happy to respond. If you have any challenges or you run into any issues, you can reach out to me on any of my social media handles. I'll be more than happy to respond to you, or you can drop your comments in here and I'll be more than happy to respond. You should also consider joining our community. That way you have early access to videos, behind the scene content, and a lot of value added and perks that you have access to on the channel. So thank you very much for watching. I'm going to be seeing you in the next video. Cheers.